This is Math Studies, Lesson 8.2. Now we're going to talk about more properties of exponents as opposed to just what are exponents. And there are a whole bunch of rules, and I've already written them, so you're not going to have to try to copy them down. But if you're trying to multiply two bases that have different exponents, you would add the exponents together. Okay, that was the first one. If you're trying to multiply, you're going to add the exponents together. The next one is if you are going to divide, the base stays the same, and you would subtract the exponents. Third rule is if you have a power to a power, you're going to multiply the exponents. The next rule is the power of a product. If you have two things being multiplied together, make sure you distribute that power to everything in the parentheses. This is the number one I see wrong, like a different example, 7xy to the 4. Make sure that 4 goes on everything. People are always tempted to just put it on the last thing, but it's got to go on everything. And then the last one is kind of the same, power of a quotient. Make sure you distribute that power goes on everything in the parentheses, both the top and the bottom, not just the top. So this lesson doesn't have any explicit examples, so I'm just going to do one exercise from each number. So the first one is using the first rule. If we're going to multiply exponent expressions, we end up adding the exponents together. So, just picking one at random, I have a base A and a base A, so I can multiply those two together by adding the exponents. It's kind of a weird one. Maybe I should do another one. Let's do this one. AA is the same base, then I'm going to add the exponents together. 7 plus 2 actually gives me 9. F was a little weird because I just left that one. There isn't really a way to simplify that, but on example C, you can see that the 7 and the 2 go together to make a 9. Example 2. This is our quotient property. If I want to simplify, I will subtract the exponents. So let's pick letter D. My base is A on both the numerator and the denominator. Exponent of 6 on top and 2 on bottom. I just subtract those, so I have A to the power of 4 for my final answer. Number 3, we're going to use the power of a power rule, and to do that we just multiply our exponents together. So let's pick letter E, my base of P, and I'm going to do 4 times 5, and that is 20. That one's pretty easy. Number 4, I have a couple different styles, so I'll do one from the top and one from the bottom. How about letter E? I'm going to distribute the 4. So the 4 goes on the 2, and the 4 goes on the A. I'm going to take this a step farther. If the instructions aren't really clear, I'll leave it up to you if you want to go farther or leave it here. But I'm going to definitely go 2 to the power of 4 and do 2 times 2 times 2 times 2 and get my coefficient, and then I'll leave A to the 4th. And I'll do letter L. I have this 5, and it needs to go on everything. So it's going to go on the 2, it's going to go on the C, it's going to go on the D. And just like in letter E, I'm going to distribute the 5 on the 2. I'm going to go a little backwards though because I'm out of paper over here. But 2 to the 5 is 32. And then I'll leave my C5 and my D5. And, oops, I'm a little far. Number 5. It looks like there's some on this page and some on the next page. Anything to the 0 power is 1. Doesn't even matter what it is. So the answer to letter D is 1. And let's do one of these reciprocals down here. How about letter K? Whenever I have a negative power, I need to flip it over. So this becomes 3 to the 4. If there was a number there, like a -2 or a -3 or -4 instead of a -1, we'd have to go a step farther. But since it's a -1, it's really 3 to the 1 and 4 to the 1, but anything to the power of 1 doesn't change it. And let's do one from number 6. We'll do 2 from number 6. I'll do letter B. I gotta put that 2 on everything. So the 3 gets a 2, the x2 gets a 2, and the y gets a 2. Taking this a step farther, 3 to the 2 is 9. Denominator, x to the 2 to the 2. We have to think back to our power of a power rule. We're going to multiply those. That becomes x4, and then y2 stays y2. And I'll also take a look at, how about letter F? The 5 goes on everything. 2 to the 5, m3 to the 5, and n2 to the 5. 2 to the 5 is 32. m3 to the 5, 3 to the 5 is a multiplication, so that's going to be 15, power of a power. And n2 to the 5 is going to be a multiplication, power of a power will be n10. And number 7, we'll do 1 from number 7, and I will do letter E. So we're going to look at the coefficients. We have a 12 on top and a 3 on bottom. Those we're going to divide just like regular old arithmetic. So 12 over 3 is 4. Now I'm going to look at the A's. I have an A2 on top and a plain A on the bottom. Now what we need to remember is that invisible 1. If it's just an A, there's a 1 on that A. Same thing with the B. There's a 1 on the B as well. So I have an A2 on top and an A1 on bottom. Quotient rule tells me to subtract my coefficients, or subtract my exponents. So A2 minus A1 is A1. B3 on top, B1 on bottom, 3 minus 1 is 2. I'm going to simplify this because we normally don't write a power of 1, but it's really, the same thing. Okay, I talked really fast because there were so many different examples, but I'm hoping these are pretty simple because they're things that you should have seen in Algebra 2 and the things that you should have seen in Algebra 1, just reviewing all of our exponent properties. So good luck with the exercises that we did not do together, and please let me know if you have questions.